Hello guys, so in today's video we are going to discuss the solution of the problem minimum distance between two numbers. Okay, so let us look at the problem statement. So the problem statement says that we are given an array of n elements. So this is the array which is given to us and it contains n elements. Find the minimum index based distance between two distinct elements of the array x and y and return -1. Return -1 if either x or y does not exist in the array. Okay, so basically n is the length of the element and the array is given and x and y is there. So x is 1 here and y is 2, and we need to find the index based distance between these two elements. Okay, so let me explain this. So let me move here. Okay, and let us look at what does it mean. So what it says basically is that here x is what? X is 1 and y is 2. Okay, and the array which was given to us is basically, let me just have the array. Okay, so the array was 1, 2, 3 and 2, and the indexes are 0, 1, 2 and 3, right? So x index, right, if you see where all x has occurred, so x is 1 and x has occurred here. So x has occurred only at one position, which is this. So x index is just 0, whereas y index is what? Y has occurred at two positions, which is this and this. Okay, so y index is what? 1 and 3. So now, so these are the indexes where x and y has occurred. So now the pairs which we'll get is basically 0 comma 1, right, and the other pair will be 0 comma 3. So these are the two pairs you will get, and the difference between 0 minus 1 and here is the absolute difference, and 0 minus 3, again the absolute difference is 1 and 3, and the minimum of 1 and 3 is basically 1, right? So 1 is the answer to this, or 1 is the minimum distance between that. So that's about the problem statement. Now let us look at the solution. So the first thing which we are going to do is basically we will look at the brute force solution of this problem. So let us look at the brute force solution. Brute force solution. So as the brute force solution, which is evident from the when I was explaining the problem statement itself, is that for given array we will create x index and y index, and having x index and y index we will compute the distance between x index and y index for all the possible pairs, and the minimum distance between all the possible pairs are our the minimum distance is will be our the minimum distance which we want to calculate. Okay, so let me explain what do I mean by this. So for this, let us take an example, and let's say that the array contains various elements, and let us say the elements are 5, 1, 1, 2, 4, 1, 6, 7, 2 and 2, and let's say x is what? X is 1 and y is 2, right? And let me write down the indexes also: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the value of n is 10. The number of elements is 10 here. Okay, so the brute force solution basically says is that I will see on what all places x occurs. So x is what? X is 1, 1, 1. The occurrence of 1 is where? Here, here and here, right? And the occurrence of y is where? Y is 2, here, here and here, right? So the indexes of 1 is what? 1, 2 and 5, whereas the index of y is 3, 8 and 9. Okay, now what we will do is that we, for all x or for each x, we will iterate on y and we will compute the difference between y and x, and by doing so we will calculate all the differences between the pairs and we'll find the minimum one there. So what I essentially mean to say is, given x and y, so all the possible pairs are what? 1, 3, then I have 1, 8 and 1, 9, right? This is one set of possible pairs. The others are what? 2, 3, 2, 8 and 2, 9. Similarly, here 9 pairs are possible, so let's look at them. 5, 3, 5, 8 and 5, 9, right? So these are the pairs which are possible here, and let us calculate the absolute difference between two. So 1 minus 3 and mod basically, so this is the absolute difference here is 2. Here 8 minus 1 is 7, 9 minus 1 is 8, here it is 1, 6, 7, 4, 3 and 2. So what is our answer? Well, the minimum distance is this, right? It will be given by this, and this will be our answer. Okay, so that's about the brute force solution. So in the brute force solution we require, so let us analyze the running time and the auxiliary space we need here. So the brute force solution first requires, in worst case it is possible that half of the elements of the array contains x and half of the elements of array contain y. So in such cases we need order of n by 2 space for x for storing x index, and similarly n by 2 for storing y index. So in a sense we need order of n space, right? And the running time complexity will be given by, iterating on the array, so for which the running time will be for order of n for iterating on this, and then we also have to iterate on x and y's, so that will be order of n cross n, which is order of n squared in worst case. So the running time complexity would be order of n squared plus the auxiliary space we need is order of n. So that's about the running time complexity and the space complexity for the brute force solution. Now let us see if we are able to optimize this solution or not, right? So let us look at the optimal solution for this problem, and let me just write it down. Optimal solution. Okay, and the optimal solution basically relies on two facts. Okay, one is, do we really have to go ahead and compute all these pairs, all values of these pairs, all the pairs? So in this case there are 9 such pairs. Do we really have to calculate the values of 9 pairs? That is one optimization we will do. And the second optimization we will do is that basically, do we need to store all the indexes? Okay, so those are the two optimization we will do, and we will optimize our problem statement. Okay, so for that let us construct our array one more time. So our array consists of elements 5, 1, 1, 2, 4, 1, 2, 4, 1, 6, 7, double 2. Okay, double 2. And let me use the indexes also. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now let's see. So the first thing we will see is that x index. Okay, we need basically x index, and we need something and similarly we need y index. Okay, so y index. Apart from these two, we will also have minimum, which will contain the minimum distance. Okay, so this will contain minimum distance. Okay, All right, so what we will do is that we will start this value as -1. -1 basically indicates that so far I have not encountered x or y, and here x is what? X is 1 and y is 2. Okay, so -1 simply says that I have not encountered x as such. So let us say index equals to, and index is the iterating counter. So index, let's say we start with 0. Okay, so we are at 0th index, so we are at this index. Okay, and we saw that this is 5, which is neither x or 9 or y, right? Not equals to 1 or 2. So we don't do any manipulation and we move to the next index. The next index is this 1, and at this value we got it as 1. So in this particular case, we will go ahead and update our x index to the position where we have obtained it. So and x index is 1. Remember this one, we have obtained it at this position, so that is 1. And y index is -1 because we have not encountered y so far, and the value of index is 1. Okay, now what? Now again we move forward, and now we are at this position, right? We are at this position, so now x index is 2, right? So now we have two values for x index. So x index was initially 1, now we have encountered 2, and y index is not known so far, right? So y index is not known, and that is -1. We are representing it by -1. Now, do we really have to maintain this one, or do we really have to compute do we really have to compute the pairs which will be generated by this one? Let us understand that. Okay, to understand that, let us assume that y will occur. I mean, we know that y will occur. So far we have not observed y, right? So we are at this position and we have not seen y so far. So y will occur somewhere here, right? Between 3 to 9, isn't it? So we can say that, let us say y occur at index I. So I has to be greater than 2, right? That we can safely say, right? Now let us see the distance or the differences between 1 and 2 and I, right? So the pairs, let's say y occur at index I, so the pairs it will form is I minus 1 and I minus 2, right? And the absolute difference, okay? So it will form these two pairs. Now let us see, which pair is minimum, right? So clearly this pair will be minimum, right? I minus 2 is less than I minus 1, isn't it? So in a way, when y is unknown and x we are observing it for the second time, then we don't really have to maintain x, or we don't really have to calculate any um, pairs including x equals to 1. So in a sense, what I am saying is that in the optimal solution, so remember, we were computing all these 9 pairs, the differences between all these 9 pairs, and from the optimization we can see that we don't really have to compute this part, right? 1 comma 3, 1 comma 8, 1 comma 9, we don't really have to compute it, because 2 we have seen 2, or we have seen the next index of x at position 2 when y was unknown, right? And when y was unknown, we have observed it at the next position, then we know that I minus 2 will always be less than I minus 1, because of which we don't really have to compute the pairs which comprises of 1, right? So let me write down the first optimization which we did. So the first optimization which we did is basically, let me say it as case 1. So case 1, x is observed again, right, when y is unknown, right? So far we have not observed y, So far we have not observed y, but we have observed x twice or more than that, right? In such cases we don't have to store x, right? So in this case we can discard earlier, or let me write it as previous, rather previous occurrence of x, right? That is what I have explained it over here, right? So as you can see now here, in the brute force solution we had to compute all the 9 pairs, but here we have just straight away we know that this will not give us our valid answer, so we can disregard it. So that is one level of optimization we did. And the second optimization, as you could have observed or guessed it, is that since we don't really have to operate on one, so we don't have to save it anywhere, so we can directly disregard that, right? So what I'm saying is that here, rather than maintaining it in the list form, we can just directly say that x index now has been moved to 2 and y index is -1, right? And here our current index is 2. Okay, so that is one level of optimization. Now from this itself we can say that the second optimization, or the second case which could occur, is that x is observed again when y is known, right? Let me explain this. What do I mean by this? X is observed again. So x we have observed it at some position I, and now we are observing x at some position k, right? Okay, and y is known in this time. So let us say y is at this position, right? So in such cases, do I really have to maintain this I, or do I really have to compute I minus j, right? So here if you see the possible distance calculation which will happen is basically j minus I plus k. Okay, this is absolute. And the second calculation which will happen is basically j minus I, right? So these are the two pairs it will form, and these are the two calculation we will do. So now in this part we can say that, or we can, from here we can see that this particular portion or this pair is the minimum. Between these two, this is the minimum pair, right? And since it is the minimum pair, we don't really have to compute any of these. And since we don't have to operate on I, so we can disregard I also. So in a sense, what will happen is that x, if we are observing x the other time, so x index, we will straight away go ahead and update x index to I plus k, right? And y will be j. And then we can just compute the difference between these two. So for the cases when x is observed again when y is unknown, in this case we will update x index to the latest one, okay? So these are the two optimization we will do, and with these two optimization we will be able to find all our pairs. Okay, so this is the optimization we will do, and let's run over the running time complexity. So first is space complexity. Let us look at the space complexity. So space wise we are not using any extra space, so the space complexity we need is order of 1, and the time complexity is basically we are just iterating it over the array one time, so which is order of n. Now let us jump to our coding section to code this. So okay, so this is the coding part and I have already coded it. Now let us look at the solution. So I'm starting with x index as -1 and y index is -1, which essentially says that so far we have not observed x or y, and then index equals to 0, 1, and minimum I am starting it with some positive infinity. Similarly, the difference also I'm starting initializing it with positive infinity. Now I'm iterating on the array, and I'm seeing if I'm observing x or I'm observing y. If I have observed x or y, I will change the index to index, and once we have that, then we will calculate the difference between x and y, right? X index and y index. And this is basically if they are not equals to -1. Basically, if we have observed it, then only we should go ahead and compute the difference. And once we have computed the difference, we will compute the minimum value between minimum value we have obtained so far, and then that minimum value is what we will return it over here. Okay. So yeah, and then there is one more case is this: if either x or either y is unknown or it does not occur in the array, then we have to return -1 as per the question. So that is what we are doing. So if you see this, return -1 if either x or y does not exist in the array. So that's about the coding aspect. Now let us submit this solution. Okay, so the solution got accepted, and yeah, that's about it. That's about the video, folks. If you have any questions or concern about this video, please feel free to use the comment section and I will try to address them. Thank you.